Hello everyone. In this short tutorial, we will see how to model a tightened and wrapped shape to obtain something visually similar to a candy wrapper or a bag closed with a string in a non-destructive way by using curve objects in Blender 5. What we need to do is define the base profile, extrude it, and then narrow and rotate some parts of the extrusion. We can perform these operations using curve objects by modifying only a few control points. Let's start by defining the profile. We do this by creating a Bezier circle object, which we can modify as needed by moving its control points in edit mode and adding new ones if necessary. Let's call this object shape. In object mode, let's now add a Bezier curve object and flatten it in edit mode by selecting all control points and scaling them to 0 along the y-axis, which is the axis along which the bulge of the initial shape develops. I am also shortening the handles of the individual control points by scaling their handle points. Let's call this object extrusion path. By default, a newly created Bezier curve has only 2 control points. But in this case, as well, we can add or remove some in edit mode. I add 3 between the initial control points using subdivide in edit mode. Extrusion path is initially straight and represents the path along which to extrude the Bezier circle created at the beginning, which we called shape and which represents the profile to extrude. To perform the extrusion, select Extrusion Path and set Shape in the Geometry Bevel Object field in the Object Data tab. Both the Shape object and Extrusion Path are still editable, both in Object mode and in Edit mode. Any changes to Shape, even in Edit mode, will have immediate effects on the Extrusion Path object. To narrow the shape we created at specific points, we need another Bezier curve object. We can duplicate Extrusion Path in Object mode and remove the reference to shape from its Bevel object field. Let's call this object Deformations. To make Extrusion Path be modified by Deformations, select Extrusion Path and set Deformations in the Geometry Taper object field in the Object Data tab. At first, extrusion path will become thinner until it is essentially invisible. This is due to how an object used as a taper object, which in our case is the new deformations object, defines the thickness of the object that uses it. Specifically, we need to move the control points of deformations in edit mode along its y-axis. The control points of deformations therefore correspond to points along extrusion path. To restore the previous appearance of the extruded profile of extrusion path, select Deformations and, in Edit mode, move all its control points along the y-axis. When an object is deformed in Edit mode, its origin remains in place. The thickness of extrusion path at its various points is therefore determined by the distance between the control points of deformations and their original y positions. Since these are curve objects, we can obtain smooth transitions between one control point and another. To create a narrowing at a specific point of extrusion path, simply select the corresponding control point in deformations and move it along the y-axis. If the control point does not correspond to the point on extrusion path that we are interested in, we can always move it along the x-axis or add more control points and deformations using subdivide between selected control points. We can also move the handles of the various control points to modify the shape of the connections between them. To rotate a portion of the extruded profile and create the impression of a twist at that point, select the corresponding control point in the extrusion path object and use the tilt tool, available with the Ctrl-T shortcut, or by changing the value in the Transform panel of the 3D viewport. All these objects are still curves, so it is still possible to modify the original profile or the definition of the control points of deformations in a non-destructive way before converting extrusion path to mesh for further editing. We can therefore modify the initial profile shape or add and move additional control points both in extrusion path and in deformations, adjusting the tilting of those in extrusion path until we reach a good result. As you may have noticed from the steps shown on screen, to obtain a good result you need to try several adjustments. It is not enough to apply tilting only to the control points of the portion we are interested in. It will also be necessary to modify the tilt value of other control points. To reset the tilting of one or more control points of extrusion path and start over, select the control points and press the Alt-T shortcut. Conversion to mesh is done by selecting extrusion path in object mode and then choosing Convert to Mesh from the object menu, available with a right-click in the 3D viewport. The number of subdivisions of the resulting mesh depends both on the number of control points of the extrusion path curve and, above all, on its resolution preview value in the Object Data tab. You can try a value, perform the conversion, examine the result in Edit mode, and if needed, undo the operation and try a different value. After the conversion, we can delete the shape and deformations objects, which are no longer needed, and start modifying the extrusion path object using the typical mesh editing tools, starting with proportional editing in Edit mode and moving on to tools such as cloth simulation or sculpt mode, depending on what we want to achieve. That's all for this video. If you found it useful, you can thank me with a like and by subscribing to the channel. See you soon.